Okay, so in this video, we're going to talk about measures of position. We're going to be talking particularly about fractiles and box plots. So a fractile is similar to a median. Is a number that partitions ordered data set into equal parts. So, for example, a quartile is going to be the numbers that separate the data into four equal parts. The first quartile would be 25% of the data is to the left from the rest of it. The median is the second quartile. Yeah, the median is the second quartile because the 2/4 is 1/2, so half of the data is to the left. So for the first quartile, when we call it Q1, it's going to be about 1/4 of the data fall on or below the value of Q1. Q2 would be the median because 2/4 or half of the data is to the left. Q3 would be the third quartile, and the Q4 would just be the maximum. So we don't ever talk about the Q4. So how do we find quartiles? Well, if you have a large data set, the software is going to do it for you. We're not going to ask you to do it by hand. In a classroom, we might ask you just to do small samples, small data samples to data sets to use it. Imagine you're cutting a cake in four. You usually don't just cut 1/4, you cut it in half, and then each half again, right? So that's what we do with quartiles. You first find the median. It's easy to find the median. Then you have the two halves, the lower half and the upper half. You find the first half. You basically find the median of the first half, right? What value cuts it in half, and then the median of the second half. So we call that the Q1 and the Q3. So you find the median of the lower half and the median of the upper half. So let's go with an example. These are the numbers I've been using in my past examples if you're watching these videos. So the values of 10 scores from an algebra class. Here, let's find the quartiles. So the first thing to do is find them in order, right? Write them in order from smallest to biggest. So the midpoint, I have 10 data points. So around here is the median would be the average. In this case, I take the average of these two values, right? So the median would be 74. It's the average of 68 and 80. Now, how do I find the first quartile? So I'm going to consider only the first half of the data. So up to here, that's the first half of the data, and that's the second half of the data. Now, this is different if we had an odd number of data, right? Right now I have an even. So to find the median, you can take the average of the two middle points. And then to find the quartiles, you have nicely 1/2, and it's the second half of the data. If I had an odd number of data, it's like a little bit of ambiguous what to do because the midpoint, the middle data would be the median for sure. But then what do you do for the two halves? Should you include it in that half and also as part of the upper half? Should you exclude it from both? Right. So it's not a big problem. Again, these things only arise when we do these small examples for a class. But you talk about medians and quartiles. Usually have large data sets and think about thousands of data. So it's not going to make a big difference if you have an even or an odd number of data points. Most of them are going to overlap. Are going to be so close that you're not going to notice any meaningful difference. So I hope you don't encounter any problems with that. But in this example, so the first half of the data were these, so I only consider those. And so the median of that first half, which would be my first quartile, would be exactly the value of 60, right? So then to do it for the second half, now I'm going to do that second half, the upper half, and the median of those values would be exactly the middle value, which is 80. So that would be my third quartile, the 80. So that's the first quartile, that's the third quartile, and the median was right the middle here of those two. Okay. So some instructors, when we give you small data sets to find the quartiles, we are very careful to give you an even data, say a data set with even numbers, an even number of data points. That way you do exactly here. You cut the median is the average of the two middle points. The first half has a median. It's well defined, the first half and the second half, and you don't have that problem if you have an odd number. But if it happens, just do one way or the other, and we should grade you accordingly. It's not a problem. What do we use the median and the quartiles for? Well, The first thing we're going to talk about is the inter-quartile range. We're going to just call it the IQR. The IQR is the distance between the first and the third quartile. So what's the distance? How far away are the Q3 from the Q1? So in my example, that IQR is 20, right? Q3 minus Q1 is 20. The IQR is 20. What do we want that for? Well, what do we want that for? Well, the IQR is going to it's going to be one of the ways we're going to define what an outlier is. So there are a few ways to define what an outlier is. The one we're going to focus on and focus on an introductory course is the one that uses the IQR. So you have your Q1 and your Q3. So probably change this one. So you have imagine you have a number line, and I have the Q1 and the Q3 over here. So this is the IQR. So you multiply the IQR by 1.5. So that distance times 1.5 would be something, let's say that and half of it. So something like that. So I don't know where my data points are, but assume I have a number line and I have some values like here and some values over here. Okay? Something like that. So you're going to grab the IQR and start it from the Q3. If there are any values of the right end of that would be an outlier. If there's, and then put it here. If the only number is on the left of that would be an outlier. This is what I try to say in this sentence. Any number above more than 1.5 times the IQR to the left, to the right of Q3 or to the left of Q1 would be considered an outlier. If you don't have any data points in there, then the data set does not have any outliers. So an outlier means a data point that is atypical from the core of the data set. Yeah, like if you have income of students at a college, or if there might be one student or two who are, I don't know, own a company, or their parents are the CEO of a company, so they might be an outlier for the rest of the class. Or if there is the homes sold in a month by a real estate agency, maybe most of the homes are in the price range, but there was one agent who sold a home that was a mansion that cost millions of dollars. So that would be an outlier that's atypical from the rest of the data points. So we can quantify those outliers until, and in the picture, one way to visually kind of see what's going on is making this the 5-number summary that we put in a box plot. So the 5-number summary is going to have the minimum, the maximum, and the 3 middle quartiles, the Q1, the 3 quartiles, Q1, Q2, which is the median, and Q3. So when you have those 5 numbers, we call it the 5-number summary, you can make a box plot. And the box plot is this bar, just a number line, where this is the lowest number, the minimum, this is the maximum. You put a line here on the median, the second quartile, and you put a box between the Q1 and the Q3. Notice that the Q2 bar, this line that you put in the Q2, doesn't have to be in the middle, right? That depends on how the data is distributed. So that Q2 to be closer to Q3 or closer to Q1, depending on how the data are, right? The only thing you know is that there's 25% of the data in each of these 4 pieces. For example, if my data was 80 data points, I have 20 points in here, 20 points in here, 20 points here that could be more clustered if it's a smaller box, right? And 20 points in here. Okay, you don't know exactly where they are, but you have 20 evenly distributed in those 4. You have the same number of data points on each of these 4 pieces. So that's the basics box plots. There are other words. This is the one we use in the basics class. You call these the whiskers sometimes, and sometimes we do. There's another one that includes the outliers, some information about that, but we're just gonna keep it like this. It has the minimum, the maximum. An example: this box plot has Q1. This low one represents the minimum, so the minimum is 31. Right? This represents the maximum, so this is a score from an exam, so the maximum score was a 99. The median is, or the Q2 is the 72, right? The 56 represents the Q1, and the 83 represents the Q3. Now, question, does this data have any outliers? Well, let's find out. If I do Q3 minus Q1, it's 83 minus 56. So this is, I believe, a 27, right? So 1.5 times that, so 1.5, this is the IQR. So 1.5 times the IQR is 27, and 13.5, I believe that's 40.5, right? 27 and half, 27. So there are not any outliers, because if you do Q3 plus 40.5, you get 83 plus 40.5. That's above 100. It's 123.5. And these were scores from an exam. Nobody got above a 99. So no, there are no outliers on that side. Then on the lower end, Q1 minus 40.5 is not going to be there either, right? 56 minus 40.5 gives you 15.5, and nobody would get that score. The lowest was a 31. So there are no outliers in this data set. Now let's do another example. These are two classes under scores again. So these are the box plots and the medians and so on. So what is the median? Sorry, typo here. What is the median? Not there. That was a typo. Typo was over here. What is the median for class A? So for class A, the median would be the value that's right here. That represents the median, which is between 60 and 70, so about 65, right? Second question, class B had 86 students. How many of them had a grade below 50? So 50 is this number here. If I make that line down, that's exactly right here, right? So that's the first quartile. That means if it had 86 students, a quarter of them got a score below 50. So 25% of 86. So I would do just fine 25% of 86. This is 21.5, right? 20, and so rounding is 20, about 22 students. And the third question is saying, does class B have any outliers? Well, class B, let's see. The Q3 is 80, right? The Q1 is 50. So the IQR is 30. So 1.5 times the IQR is 45. Do I have any outliers? Well, let's see. On the top side, on the upper side, 80 plus 45, no, because Q3 plus 45 would give me 125, so nobody got a score of 125 or more. But on the lower end, if I do Q1 minus 45, get Q1 was 50, so it's a 5. And according to my box plot, the lowest was a score of 0. So yes, there is at least one outlier. We don't know how many outliers there are, okay? For all we know, if there's 86 students, maybe 22 of them are right there, right? All I know is there's 22 scattered in here, but I have no idea how they are distributed. It could be that all 22 had scores between 0 and 5, right? So that's a question that sometimes students get confused. This doesn't tell me how many outliers I have. All I know is that there is at least one, but it could be all of them, right? It could be that there are no data points between 4 and 50. All those 22 students have scores between 0 and 4, and then all 4 are there, okay? Okay, so that's that does it for this video.